an endless world of ice. There exists a living nature. One that we must protect. The Arctic and the Antarctic extend to the high-latitude regions at the northern and southern ends of the Earth. The midnight sun visits in summer when the sun never sets, and polar nights visit in winter when the sun doesn't show itself the entire day. Beneath the night sky, where the mystical aurora dances, is a world of ice and snow. The two polar regions are similar in many ways, but they differ in many important respects too. Antarctica is a massive continent encircled by ocean. It is covered by thick ice that averages about 2,000 meters in depth, and the lowest inland temperature approaches minus 90 degrees Celsius. It is the coldest place on Earth and an extremely inhospitable world to life forms. The center of the Arctic is a frozen sea. The Arctic Ocean is surrounded by Greenland, North America, and Eurasia. Although the Arctic is a world of ice like the Antarctic, the latter holds 90% of the Earth's ice compared to the Arctic, which holds less than 10%. Winter temperatures average between minus 30 and 40 degrees Celsius, and vast stretches of land are covered by greenery in the summer. It is home to polar bears, reindeer, seals, walrus, and many other animals. Humans have also been living in the Arctic from time immemorial. This environment, however, is now starting to undergo rapid changes. The sea ice area is shrinking, and the ice covering Greenland continues to melt. Signs of global warming are currently more prominent in the Arctic than anywhere else on Earth, and its impact on even distant Japan has become apparent. What will happen in the future? What should we do? These are questions that the countries of the world must tackle together as soon as possible. Japan's observations and research in this area are drawing interest. In the Arctic, there are villages and towns where people live. The development of industries has caused an increase of greenhouse gas emission, and the environment has changed. Arctic observations have progressed in various research fields, and more precise measurements have been obtained. This figure shows variations of the atmospheric carbon dioxide concentration observed at the Arctic and the Antarctic. They have been increasing from year to year with accompanying seasonal cycles. What is happening in the higher atmosphere? Within the atmosphere, the troposphere is extended 10 kilometers in height from the Earth's surface and is directly related to weather phenomena. Greenhouse gases are increasing and warming has intensified in the lower atmosphere. The EISCAT radar, looking at a few hundred kilometers, is operated in Norway and northern Scandinavia. Temperature and density of the upper atmosphere have been observed for more than 30 years by the EISCAT radar. Computer simulation had predicted that the increase of carbon dioxide will warm the atmosphere but cool the upper atmosphere. From the EISCAT radar observation, a rapid cooling of about 14 degrees per decade was captured. Since the upper atmosphere is thin, even a minor environmental change will appear enlarged. A long-term observation using the radar is therefore essential. To examine the upper atmospheric phenomena in detail, an international cooperative plan to construct the state-of-the-art radar EISCAT 3D is currently under development. The role of clouds needs to be understood when examining the relationship of atmosphere and warming. Clouds block the sunlight and cool the surface, but clouds also warm the surface by acting as blankets. In the Arctic, where summer is short and polar night is long with no sun, clouds have more of a warming effect. Clouds might be effective in warming amplification. Even though clouds are familiar, there are still many unsolved mysteries. It is in the Arctic Ocean where global warming is particularly noticeable. Through sophisticated satellite observations, it was clarified that the sea ice area in summer continues to decrease and is now about half the size of what it was in the 1980s. In the summer Arctic Ocean, sea ice has disappeared in an area where 2 to 3 meters of ice once existed. The sea surface that is no longer covered by ice absorbs solar energy directly, thus further warming the ocean and melting the surrounding ice. The sea ice cover has also been diminishing in the winter, particularly over the European side of the Arctic Ocean. The latest research reveals that the change in sea surface temperature over the Gulf Stream influences the sea ice variability in the eastern Arctic. The rise in sea temperature is causing the Gulf Stream off the eastern coast of the US to shift northward. The air current and lower atmospheric pressure also shift northward with the meandering of the westerly jet stream. Then, the southerly winds over the North Atlantic and Scandinavian region deliver the warm air masses into the Arctic. This warm advection from mid-latitudes contributes to the warming over the Arctic Ocean and decrease of sea ice. Over the Eurasian continent, in contrast, an unusual cold condition is formed because the warm air does not reach there due to the meandering of the westerly jet stream as well as the enhanced cold airflow from the Arctic Ocean. During the winter season, this cold air over Eurasia blows off to the eastern Asian countries and sometimes causes heavy snowfall in Japan. In the Arctic, Ice covers not only the oceans, but also the land. Greenland, the world's largest island, is covered with thick ice. If all the ice completely melted, it could raise global sea levels by 7 meters. The amount of ice has actually been decreasing over the last 20 years or so. The warm atmosphere is not the only cause of melting ice. There are microorganisms on the surface of the ice. It has now been revealed by recent studies that they turn the color of the snow surface black or brown, causing more absorption of sunlight and therefore more melting. How have the past climate and environment varied, and how does that compare with recent rapid changes? Greenland's thick ice is made of compressed snow, and the ice near the bottom is more than 100,000 years old. We can study how the past climate and atmosphere varied over time. This is done by collecting the ice and investigating its composition, including trapped air. International efforts are ongoing to understand the Earth from past to present and better predict its future. The environmental changes in the Arctic Ocean are affecting sea life. For example, the disappearing sea ice has made life difficult for animals that rely on the ice, such as polar bears that hunt from the top of ice floes. And what about organisms that live in the oceans? Japanese research vessels, such as the Midai and the Oshoromaru, are studying Arctic Ocean environments in which plankton and fish live. We have learned, for example, that phytoplankton, which sustains ecosystems, becomes more active with exposure to additional light as sea ice disappears. Accompanying changes have been seen in the ecology of zooplankton and fish. Rising seawater temperatures and changing currents are also impacting the habitat of fish and other marine life. At the same time, as the amount of carbon dioxide in the atmosphere rises, more will be absorbed in the oceans, furthering their acidification. In particular, the disappearance of sea ice from the Arctic Ocean will expose long-covered waters that will absorb carbon dioxide more rapidly. Further acidification of the oceans will hamper the breeding of shellfish, prawns, and sea urchins. We can also see changes in plants, one of the key factors being permafrost. Japanese scientists have observed permafrost and plants for many years in Siberia and Alaska. They found that photosynthesis may decrease in some plants if global warming accelerates the thawing of permafrost and increases the water content of the soil. It has been observed that trees have died because of too much water in the soil. And there are concerns that thawing permafrost may induce increased greenhouse gas emissions from the soil into the atmosphere. The Arctic summer sea ice area continues to shrink. However, there are endeavors to make use of this development. If large cargo ships are able to pass through the Arctic Ocean, the distance traveled will be shortened by more than 30%, and they could save significant time and fuel compared to the route through the Pacific or Atlantic Oceans. This underscores the need for early, accurate forecasts of when and where the sea ice will disappear, allowing ships to pass. Research is looking at how to improve the precision of such forecasts. Japanese researchers are active in these areas. The National Institute of Polar Research and other major institutions have established observation stations for Arctic research and share these facilities with researchers from other countries. There are several stations that support researchers and serve as locations for observations across the Arctic. In Alaska, the IARC. In Siberia, the observation sites in Yakutsk. In Iceland, the Aurora observation sites. In Scandinavia, the Upper Atmospheric Observation System, the EISCAT radar. And experts of polar studies come to teach from all over the world at UNIS. Ny-Ålesund at 79 degrees north on Svalbard is a unique place with over 10 international research stations. Japan opened an observation station here in 1991. Here, researchers continue to carry out atmospheric and biological studies, as well as ice, snow, and oceanographic studies. The Arctic is home to people of many countries. We hope to build more international and cooperative relationships. Japanese researchers have continued to make observations at various sites in the Arctic. Research institutions and universities are establishing partnerships with one another in order to achieve more effective observations and research outcomes. Japan also strengthens international collaboration among countries conducting research in the Arctic. The National Institute of Polar Research will lead Japan's Arctic research and is intending to build up a cooperative network. More than ever, we must keep our eye on the Arctic, which has a huge influence on the Earth's climate and even on our society and livelihoods.